Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikram bin Wahab. Today, I would like to present my PSM2. The title is The Evolution of Dendracalamus Asper, Buluh Betong as a pulp and paper product using alkaline pulping method. First of all, I would like to present the abstract from my research. This research aimed to determine the potential value for pulp and paper making using 15% of active alkali AA charge on Dendracalamus Asper Buluh Betong. Soda pulping was used for pulping process. The condition of pulping that were used are 15% AA with 1.5 hour and 2 hours cooking time. The pulp paper production and properties were conducted according to TAPPI and MS ISO standard. A basic weight of 120 JSM was used for paper sheet formation. Pulp from 1.5 hour cooking time results in 48% of screen yield, whereas 2 hours results in 48.25%. 1.5 hour cooking time provided the strongest tear and tensile strength index with the value of 8.57 and 11.26 respectively. However, the 1.5 hour cooking time showed lower burst index with the value of 3.06. Meanwhile, 2 hour cooking time results in tear strength 2.96, tensile strength index of 1.57, however higher in burst index with the value of 3.08. Based on ANOVA analysis, there is a significant difference for tensile and tearing strength except for bursting strength. There is no significant difference between both pulping conditions. Based on overall result, it was clear that 1.5 hour cooking time contributes to best pulp production. Buluh Betong fibre with the soda pulping characterization has high potential to be used in the production of paper making industry. The finding of this study will also serve as a disclosure to establish and innovate sustainable paper production while preventing environmental contamination. Moving on to introduction part, the pulp and paper industry are one of the most important in the world. As we know, the paper is the most important that we use every time in daily life, such as newspaper, notebooks, magazines, periodicals, tissue, glossy papers, and paper-based packaging are all produced by the paper industry. Malaysia, like most countries, still relies on import raw materials for pulp and paper production. One of the materials that can solve this problem is bamboo. Bamboo is a plant that belongs to the grass family and is one of the most extensively used non-wood raw materials in Asia for the production of paper and paperboard. As a non-wood pulp source, bamboo is utilized in the production of paper and board. Bamboo fibers also are superior source of raw material for pulp production. They also contain a wide range of physical and chemical characteristics that may be utilized to produce different paper grades. As a result, it has become necessary to characterize their pulps and determine their stability for paper manufacturing. Next, we move to the literature of the research. According to Ang 2010, most studies showed a clear decline in screen yield, reject yield, and kappa number as the cooking time increased within the usual pulping temperature range of 150 Celsius to 190 Celsius. Soda pulping is a chemical pulping procedure that uses sodium hydroxide as a delignification chemical. According to Kutiraja 2013, soda pulping is the process of processing biomass materials with an alkaline such as NaO to induce lignin to be solubilized by deprotonation of the phenolic lignin subunit. Meanwhile, from Bryce 1980, In alkaline cooking, the amount of active alkali charge varies depending on the wood species used, the degree of delignification required, and other factors. ANOVA is a statistical approach for dividing observed aggregate variability in a data set into two parts, systematic and random components. Last but not least, SAM, an instrument in which the specimen surface is scanned by a focus beam of electrons by sweeping it across a rectangular shaped area, which is called raster, and using a variety of detectors, the image is reconstructed from the signals regenerated from the sample and magnified on the screen. Next, move to the methodology part. Three main materials that were used in this research is bamboo, sodium hydroxide, and distilled water. First of all, Buluh Betong chip were cut into 1 until 2 cm length, and the amount of sodium hydroxide and also the amount of distilled water were determined by using calculation that had come before. And then these materials were mixed into the rotary digester and heat up to 170 Celsius for 1.5 hours for first condition and 2 hours for second condition. After that, this material will become a pulp and will going through for pulp properties determination like screen yield, reject yield, and freeness. After that, pulp will pulp going through the paper making process for making a paper sheet, which is 120 GSM from two pulping conditions. After the paper sheet become a paper, the paper going to a sample testing like structural properties and also mechanical properties. For structural properties like grammage, thickness, and apparent density, and for mechanical properties like tear strength, burst strength, and also tensile strength. All the data will analyze using ANOVA. Last but not least, the paper will going the scanning electron microscope for last results and discussion. Next, we're going through about the results and discussion for this research. The following graph shows the result on mechanical properties analysis of paper as templates in the table below and morphologies of paper by Sam. For first graph, ANOVA analysis shows that there were significant difference between both 1.5 hour and 2 hours cooking time, where they were not in the same group of means. From the results, the tear index for 1.5 hour was higher than 2 hours and the standard deviation was quite high as shown in the picture. In 2 hours cooking time, the results show low due to carbohydrate dehydration and manual handling during pulping. The difference shows that the interaction fibre in the paper improve the physical properties on certain amount of the dosage. Next, for bursting index, according to bursting strength, ANOVA analysis shows that there were no significant difference for both 1.5 hour and 2 hours cooking time samples where they share the same group of means. As can be seen in picture, for sample 4 of 1.5 hour and 2 hours cooking time, the bursting index was high as the fiber bonding may be accumulate at those area that was tested. When the tensile breaking strength of two paper is equal, usually the one with the greater stretch has the higher bursting strength. Last, for tensile, ANOVA analysis shows that there was significant difference between both groups of data. 1.5-hour samples show stronger mechanical properties of tensile strength compared to 2 hours samples. This could be because the carbohydrate dehydration in sample 2 hours is higher due to the longer cooking time compared to 1.5 hour. This situation also might be due to the cooking time that suitable for pulping buluh betong was 1.5 hour. And then we move to the surface morphologies of paper, which is 1.5 hour and 2 hours at 200 magnification. For SAM, it shows image of surface morphologies of paper 1.5 hour and 2 hours at 200 magnification. 2 hours cooking time, the morphology showed many voids, fibre pull out and fibre broken. Void area will show low burst strength results and the paper either strength or not. Meanwhile, at no void area will show high burst strength. From this, can see the uneven distribution had occurred at certain part. Besides, from picture showed a single fibre broken, which is red color, and fibre pull out, which is yellow color. Thus, the morphology of paper sample using SAM to confirm these findings. From broken fibre at 2 hours cooking time showed the fibre uneven cooking like overcooked and uncooked during pulping, which show the result not consistent. Thus, from morphology prove whether the paper is strong or weak due to uneven cooking. In conclusion, the research objectives have been archived. For number 1, to produce a pulp from Buluh Betong using alkaline pulping method. Number 2, to evaluate the structural and mechanical properties of Buluh Betong paper according to TAPPI and MS ISO standard. And number 3, to characterize the morphology of Buluh Betong paper using scanning electron microscope SEM. Paper properties, pulp properties, significant difference. The mechanical strength properties of the Buluh Betong pulp base are good. The structural and mechanical testing based on varied Buluh Betong cooking time has been carried out and analyzed. It was clear that 1.5 hour cooking time contribute to best paper production because of the higher volume of tensile and tear using ANOVA, except for bursting strength. Buluh Betong fibre with the soda pulping characterization has high potential to be used in the production of paper making industry. The results of this study will be used as a disclosure to build and innovate sustainable paper production while avoiding environmental pollution. That's all from me. Thank you.